All right, so now finally, example one, write the expressions as a sum and or difference of logs, express powers as factors. So example one has to do with our last three properties that we just went over. It has to do with this. So notice these are all one log, right? You've got natural log, you've got log base 4, so it's one log. I need to take these one logs and I need to expand it out. So if these are being multiplied, we'll expand it out with a plus. If they're being divided, we'll expand it out with a minus. And then it tells me to express my powers as factors. And so I need to take whatever my power is and move it to the front and write it like this because this is now a factor. So the first thing that I am going to do is let's talk about the relationship going on between everything here. We got log base 4. This is x times x minus 9. So when I expand this out, this is log base 4 of x. These two are being multiplied. So plus log base 4 of x minus 9. Okay, so that's that top portion right there. Then this is all being divided by, so now I will go minus log base 4 is being divided by x plus 2 to the 7th power. There's not really a lot of simplifying I can do here, but I do need to make sure if I have any powers, I'm expressing them as factors. And I do have a power, this 7 right here. So my final answer is log base 4 of x plus log base 4 of x minus 9 minus, I'm going to move this 7 in front. And so minus 7 log base 4 of x plus 2. Okay, same thing here. We have the natural log of x squared. These are being multiplied together. So we'll do plus the natural log of 1 minus x. Okay, we can express this as a rational exponent. So we've got the natural log of 2 plus the natural log of 1 minus x to the 1/2 power. So remember, this is a square root, so my known index is 2, and this is all to the first power. So that power stays as the numerator, and whatever is the index comes around as the denominator. So square roots become 1/2. So then lastly, again, express your powers as factors. So this 2 is going to come around to 2 natural log x, and this 1/2 is going to come in front. So plus 1/2 natural log of 1 minus x. Okay, so now in example 2, let's go the opposite way. I now need to write this as a single log. Here I have 2. And here I also have 2. So the first thing we're going to do is the last thing that we did here, which is always move those exponents in front to factors. So when I have factors here, I need to move them back to exponents. So we've got we've got log base 2 of s to the 10th power plus log base 2 of t to the 6th power. Once I get these as exponents, whatever my factors are, now because this is a plus, I'm going to multiply. So we've got log base 2 of s to the 10th, t to the 6th. So there is my single log. So you take your factors first, move them up to exponents, and then multiply if it's adding or divide if it's subtracting. So here I do have one factor, so I am going to move this up. And I'm going to kind of do this all in one swoop here, okay? So I'm going to move this 5 to become to the 5th power, and then I have a minus here, which means I'm going to be dividing these log base 7s. So we've got log base 7 of x squared minus 64 over x plus 8 to the 5th power. I know I'm dividing these two here because of this minus, and that 5 comes up as an exponent. Now you might think that we are done, but we can simplify this further. If you want to star this, this is a test question. This is a difference of squares that factors to x plus 8, x minus 8. I'm going to keep this all over x plus 8 to the 5th. And so if you notice, we have common factors. We have an x plus 8 on the top, and we have 5 of them down here on the bottom. So the 1 on top goes away, and this 5 goes to a 4. So my final answer is log base 7 of x minus 8 over x plus 8 to the 4th power.